The idea of feedback loops was vaguely mentioned in a previous video. So a feedback loop is a small change, such as a decrease in snow cover, that can be amplified by a loop and then have a large effect on Earth's climate. So it's a process in which the result acts to influence the original process. Feedback loops make it difficult to predict the effects of change because it can kind of be magnified sometimes. And these feedback loops can contribute to very rapid shifts in Earth's climate, such as ice ages to warmer and in interglacial periods. There are two possible kinds of feedback loops that we'll discuss. We have what's called a positive feedback loop, and we have what's called a negative feedback loop. In a positive feedback loop, the effect increases the original cause, and in a negative feedback loop, it decreases the original cause. So here's an example of the water vapor feedback loop. So it becomes much more complex when you consider, cloud cover and stuff. But more water vapor usually means more clouds. And if the clouds form relatively low in the atmosphere, then they trap thermal energy near the Earth's surface. You may have noticed that on cloudy nights, it's usually warmer than on clear nights. So low cloud cover creates a positive feedback loop. So what that means is warmer temperatures creates more low cloud cover, which creates more warm temperatures, which creates more water vapor in the atmosphere, and then that creates again, more cloud cover and etc. So it kind of just keeps looping back over and over and over and over again. If the clouds, however, form at a high altitude, then they'll reflect the sun's radiation back out into space before it can kind of reach the Earth's surface, and this creates a negative feedback loop. So if you have warmer temperatures that create low cloud cover, then you get even warmer temperatures. However, if you have warm temperatures that create high cloud cover, then we end up with cooler temperatures overall. So that's kind of the difference between a positive feedback loop and a negative feedback loop. An important idea is what we call the albedo effect. Albedo is the amount of incident light or radiation that is reflected by the surface, a planet or a moon, for example. And so if we look at the albedo effect from a warming point of view, well, ice melts and then less of the sun's radiation is reflected by the ice. So more of it stays on Earth, and then Earth's temperature increases, and then more ice melts, and then that kind of loops in a positive fashion. Positive not meaning good, but positive meaning it increases the original issue. And then the cooling version of that is that more ice forms, more of the sun's radiation is reflected by the ice, and then Earth's temperature decreases, and then more ice forms, and then more of the sun's radiation is reflected by the ice, and then Earth's temperature continues to decrease. That would be another positive feedback loop, but in this sense from a cooling point of view. Carbon dioxide is another example of a feedback loop. If we take a carbon sink, which is a reservoir, such as a large body of water like an ocean or a forest, that absorbs carbon dioxide from the atmosphere and stores it in another form. So oceans store enormous amounts of carbon dioxide, of carbon as carbon dioxide and carbonic acid. However, as temperatures rise, the oceans cannot store as much carbon. And that releases carbon dioxide into the atmosphere. This further increases the carbon dioxide that adds to the greenhouse effect, further causing temperatures to increase and further reducing the body of water's ability to act as a carbon sink. So here's an example where, again, this is not a great thing that we want to happen. This is another example of a feedback loop where the temperature is going to keep increasing because of the original issue. So the temperature goes up, the water cannot store the carbon dioxide very well. That carbon dioxide gets released in the atmosphere. That causes temperatures to go up again, and then it causes the water to be an even worse carbon sink.